Hello, everybody. Welcome to Middle School Math Adventures Live. So today we are going to cover some information about how to apply proportions and ratios into your classroom. And this is a part of the Math for Change book club. So I hope a lot of the people who are in that book club are here joining us. So today I'm going to cover ratios and proportions, but just a little bit about me. My name is Kanissa Grant. I'm the content creator for Middle School Math Adventures, and I'm also a math intervention teacher as well. So I have 10 years of experience working with students with disabilities and ELL students and making math fun and engaging for them. So we're going to discuss proportions and ratios today, and I'm going to talk a little bit about the research and the methods behind this book here. And this is one of the books that we're reading is Making of Sense of Mathematics for Teaching. This is grades 6 through 8. They have 3 through 5. They have a small group book as well. But since we're focusing on middle school, we're going to use the middle school book for this session. So we already went over chapter 1 that talked about fraction and integer operations. And now we're diving into ratios and proportions. So what's going to happen is that I'm going to go through some of the details of chapter 2 and then also just talk about some of my takeaways and things like that. I'm also using this new platform, and if there's any technical difficulties or anything like that, I'll try to get back on and do all the other stuff. But I just want to make sure that everyone is ready, locked, and loaded. If you have any questions, please leave questions in the comment box so that I can answer your questions and I can see all of your feedback. So what I'm going to do now is I'm going to dive into the books. So like I said before, I'm going to talk about ratios and proportions and how it connects to sixth grade and seventh grade content. Now, what I like to do is with my sixth graders, I like to also cover the seventh grade content as well. And with my seventh graders, I like to cover the eighth grade content. I think that this segmenting of different types of concepts when it should be represented as a whole, it gets kind of confusing. And it helps with recall as well. So students will be like, oh yeah, I learned that in sixth grade. When they're in seventh grade, they're like, okay, I'm able to actually have a better understanding. So this is just one method that I like to use in my classrooms. But in this book, where it talked about specifically how to relate ratios and proportional relationships, which I'm going to talk about in this session. So a couple of things that I'm going to go over first is kind of like the progression, because that's the most important part. Like, how do we scaffold and build the knowledge for students? So one thing that starts off with is we like to explore what a ratio is, right? And then we go into unit rate, like how do we increase, what does a ratio mean in terms of unit rate? Then we learn how to solve problems, okay? And then we apply it to real world problems. And then you make sense of proportional relationships. And then how do you determine if two quantities are proportional? And then we solve some problems with proportional relationships, and then the graphing relationships. So these kinds of things happen in between sixth grade and seventh grade. I like to kind of go through each one of the concepts and kind of touch on each one in the sixth grade, or maybe even touch on ratio relationships when they talk about fractions, because we do talk about parts of a part and parts of a whole in fifth grade as well. So I want to make sure that students are able to get that knowledge and feedback. So that's the progressionary part. So the next part I'm going to talk about, which I'm really excited about, which is the entire premise of this unit and this chapter, is talking about visual mathematics. And how we relate that to what students understand within their own environment, right? So I always like to talk about concrete examples, and usually we can talk about within the class, we can talk about ratios, right? So we talk about left-handed versus right-handed students. So if we take a tally in the classroom and we find that there are 12 left-handed students and 18 right-handed students in the class, we can come up with a ratio of 12 to 18, right? Or it's a 2-to-3 ratio, right? So it represents part of a part. And we can physically see this in the classroom because students will definitely go around and be like, oh, you're left-handed, you're right-handed, you're left-handed, you're right-handed. Even if there's one type that's more dominant, which is probably the right-handed one, you'll probably be able to provide an example and they'll be able to understand, okay, this is how this relates to this, right? So then I take that and basically I teach them, okay, if it's um, 12/18, right? That means there's 12 left-handed and 18 right-handed. What's the ratio, right? That's the ratio, right? So then we relate that to how the proportions actually work, right? So what proportion of the class is left-handed, right? So you got 12 out of 30. And then what proportion is right-handed? It's 18 out of 30. Or they should also realize, if they understand how to simplify fractions, that that's 2/5 and 3/5, right? So you'll notice that the 2 and the 3 are still incorporated in the proportion because the ratio in terms of the parts to parts is 2-to-3. So having concrete examples for students starting out in the beginning of the unit can definitely set them up for success and also get them engaged in the lesson. So utilize real life examples in their classroom environment. Another way I can do this is I like these little things called these bingo chips. They have fabulous different colors. These are perfect for ratios. The reason why is because they can see the colors, right? And for students who need more of a visual context, especially students who are ELL and have special needs, they can literally pick out different colors. So say if they pick out 12 green dots and 18 red dots, they're able to actually pick those things out and actually visualize and see the ratios. And then you can just figure out the proportions and things like that using these. They're really great. I suggest you purchase these. You can get these on Amazon. I think they're bingo chips, but I use them for pretty much any type of visual math, activity that I teach in my classroom. So this is just like one of those things that are just like really, really, really exciting for me to use. So another thing that I just recently released is the visual math worksheet. So I'm going to go through one of the visual math worksheets that I cover with my students. And this is one of my favorite things to use, mainly because this allows my students to see what the contexts are and how to apply the different methods. And it's kind of providing a scaffolding too, right? So there's layers of facilitation, as I talked about in chapter 2 of the Making Sense of Mathematics book. So I like to do that a lot so students can utilize different methods and different ways of understanding the ratios and proportions. So I'm going to share that with you right now. So this is one of the worksheets within the visual math worksheet bundle. There's going to be a lot more in there, but basically, as you can see, that we have the essential questions here, and then we have the questions. So in this scenario here, we have Lily drives 90 miles in 2 hours. If she drives at the same rate, how far does Lily travel in each of the following time intervals? Okay, so we're looking at this scenario from the perspective of Lily, right? And the ratio here, we start off with 90 and 20. So there's two ways I like to model this. One of the ways is bar modeling, because this is something that students can actually break down themselves. So the largest one at the top is going to be 90, right? Because that's the largest ratio. And then we got 45 and then 45, right? If you break the 90 in half, you get 45 and 45. So that breaks it down into the smaller intervals there. So the next part is, how do we break this down even further? So we take this 45 and we divide it into 2. We get 22.5 and 22.5, right? So that's, I'm going to just move. Let's see if we can do it this way here. Learning new methods all the time here, so you guys can actually see that. Now, then we're going to even move it, take it even further, right? And if we do the 3 hours, right? We're going to take the 135 and then we break it down into the individual 3 parts. Okay, so what you're seeing here is you're seeing the relationships between the first hour, the second hour, the half hour, and the third hour. And students are able to break this down pretty easily because they can actually see the bar method here, and be able to determine, right, based on this method, how do these relate to each other. Right. So then what we do is we do a ratio table, and this allows us to see the entire picture, the full picture. And I always start with what's in the problem, right? So she went 90 miles in 2 hours, right? So based on our previous understanding of 1 hour, right? If we break it down, right, half of that would be, right, would be 45, right? Because you're breaking down, right, the 90 and you're cutting that in half and you're getting 45 to get 1 hour, right? And then when you have the 3 hours, right, we get the 135, but we have the 3 hours. And then for half an hour, we break down the 45, just like we did up there. And we have half an hour here. Okay, so students are basically, again, scaffolding, using the knowledge again to basically determine, okay, how do these different ratios relate to the rates that she completed for 1 hour versus 2 hours versus 3 hours versus half an hour. And then this is more of like a seventh grade concept with this graphing, but I like to actually utilize this in the sixth grade as well. And graphing is one of those things where they can learn how to use the coordinate plane, and be able to determine. I'm going to take this thing off so you guys can see this. So then I'm just going to try to graph really quickly the 2 dots here, and hopefully I can make a straight line. But they should see, so this will be miles, this will be hours here, right? And they're learning about the ratio or the unit rates here, which they should understand, and how this line represents how the rate is changing as you increase the amount of hours, right? So they should be able to see that relationship, and basically they can go back to the ratio table and be able to graph that using the ratio table. So there's 3 different representations on this. And then the last part is providing evidence. How do you know that this is actually true? And this is where they write down their explanation on how it relates. So when we talk about this in the class, students are able to basically take away what they did on this worksheet and write down the evidence section. Within the text, I'm going to go back to this. Within the text, the making sense from teaching for mathematics for teaching, what happens in this book is they talk about like the TQE method, right? Which is task, questioning, and evidence. And the last part is evidence. And when you look at the videos, what they'll do is the teachers will ask the students, okay, how did you get to this point? What was your thinking about this? And you'll have students who solve this in many different ways. And one thing as a teacher, what you need to be mindful of is that there are so many different ways to solve these problems. So you got to be aware of how students are thinking and be able to tell them, hey, this is where you made the misstep. This is a misconception here. Maybe you can think about it this way. Or how about you if you add this? So it's really a conversation and a dialogue about the problem. And one of the things that I'm going to talk about now are the major takeaways of this chapter. So chapter 2 talks about ratios and proportions. And I'm really excited about the fact that there was so many different aspects of the chapter that I realized as a teacher, where I didn't really push my students as far as they could go because I was so focused on having them get the right answer and not really focused on the process, right? So the problems like ratios and proportions, these are things that by the 6th and 7th grade they have probably seen and they've experienced. And I don't really call on that experience when I'm really focused on this is how you get the answer, or this procedural teaching that most of us have been exposed to in our mathematics education. So one thing that I really like or really want to focus on more and learn how to do and improve my skill set is in terms of focusing on the process, right? So one way that you can actually do this in your classroom is not focusing on getting the answer. It's focusing on how the students worked out the problem to get the answer. So don't be like, oh, you got it wrong or this and that. Be like, but how did you solve this? Right. And sometimes students will go back and be like, oh, yeah, I missed this part. Or you can ask a question to help them get the correct answer. All of these different tests and assessments of being like wrong, right is what really creates that fear for math that really shouldn't exist and really doesn't help our students grow as learners. And it also doesn't build critical thinking skills at all. If you're like getting questions wrong all the time on an assessment, you're not going to have the confidence to be able to solve other problems. So that's just a fact. So we have to be mindful of the fact that we are supporting students, you know, math anxiety, and there's a whole other mental aspect of this that we can cover later on, but we need to be mindful of that. Also, we need to provide feedback on the process. Don't say, oh, you didn't get the right answer or that's incorrect. Go back and fix it. Because that doesn't really provide or help the students think about the problem. So that's one thing where we need to provide very direct feedback for students. Also, being able to identify misconceptions in terms of like proportions. One of the things that I and my students really struggled with is the difference between multiplicative and additive properties of proportional relationships. So there's a difference between the two, right? And being able to show those visual models will definitely be able to help your students see where those issues are. And one thing that you need to focus on as well is providing different types of problems. So there's not this one monolithic way of solving proportional relationships, and you need to not teach it that way, right? So always tell your students like this is the foolproof way of getting this and that. That is never a thing that I say in my classroom because there's so many different ways of solving a problem, and there's many different types of problems and situations. So you need to base your thinking based on that particular problem, right? Because what'll end up happening is students will go into the problem and be like, oh my God, like I applied the method, why didn't I get it right? And they won't utilize any other methods because they're like, oh, this is the one that, Miss Grant taught me. So that is one thing that you can do in order to help improve your instruction and help your students be able to understand how to solve problems in different contexts. Another thing that I love to do in my class is, and that was also brought up in this book, if you watch the videos, it was really well done, is the fact that you need to utilize student examples. And student examples are a really powerful way of allowing your students to basically explain and have it be a student-centered classroom where they can definitely challenge and understand and critically think about the concepts. So allow that space and that time for them to think, and then also have them explain their understanding. So one thing that I always like to do is it's always fearful for students to like raise their hand in the class and be like, hey, let me answer this question. But we don't really want that to happen. We want students to feel free enough to answer the question. When they get something wrong, it's not about them solved in their problem solving skills. It's just that they missed a particular step or thought about it in a different way. So we want to encourage that because that is something where it might not work for this scenario, but it might work for another scenario with another problem. And also, right, you shouldn't really just write the solution to the problem when they figure it out because it's like, oh, this person got the question right. Let me just call on that person so we can get the question right so we can move on to the next part. Critical thinking takes time. And especially for students who have disabilities and have ELL, who are ELL students also need thinking time. So moving on to the next problem or teaching them how to solve it without actually, having them explain their thought process doesn't teach them how to be independent. It's just having the teacher tell the students the answers. And we have to build in that thinking time for students to be able to really critically think about the problems. Also, one thing that was really kind of amazing, and I had to really reflect on this for myself, is my own mathematics education and how it was really procedural. And I really stick even to this day to the procedures, and I really when I think about problems and things like that, it's really, really computational. But when math is really, I think math is really visual, and we need to really capitalize that on in our classrooms. One thing about I love about this book here is being able to think about problems using the visual method. I love using algebra tiles. I love using geometric shapes, and really seeing things live helps students really touch and make it tangible, and then also apply it to the math as well. That VKA method that they talk about in education is really critical for mathematics as well. Because the thing is, in some classes, students don't talk about math; they just write it down, and that's the only method that they're really doing. Right? It's really a kinesthetic activity. It's not really like they're using the auditory or the visual as much. With this visual math, they can be able to actually utilize the V, the K, and the A all at once in one lesson. It really solidified those concepts. So it's something that I really take pride in. And whenever I think about a lesson, I kind of schedule it or plan it out in a way where they're really thinking about and really kind of thinking about those different types of processes while they are engaging with the worksheet. I think we stick too much to the worksheets and too much to the tests. And I understand when you're doing the visual math models that it's like on a standardized session, I have time to draw out all these diagrams and things like that. But maybe we should make time for that. Or maybe we should really focus on a couple of concepts and make sure students are really good at those concepts so that they can be able to be successful on these exams. And even through reading this book and understanding how to really build on this knowledge is has been like a gift because the students will benefit from this, I think, in the end. Even one of the things that they pointed out in the text that they talked about was the butterfly method in terms of the cross multiplication of, let's see if there's anything here. Um, if you guys have any questions, make sure you guys ask them. I'm going to get to the Q&A section. If there is like this butterfly method where they do cross multiplication, and what ends up happening is that theoretically doesn't help students understand proportional relationships because they're not understanding why do you cross multiply, right? They don't really tell us that or teach us that. And I never wanted to be the teacher who was just teaching a method for just for method's sake here. So I'm really trying to be mindful of that process and really learning about how to integrate more visual mathematics into my lessons. As I'm going on this journey here, I have some resources for you on the middle school math shop that's located on the Learn, Teach, Change website. And I'll include that in the outro where you can go to, and also in the description box below, where I provide the worksheets, which is the scaffolding. And then also on the YouTube channel, I'm going to talk about how to utilize visual mathematics in your classroom to help your students learn about math concepts because it's just really important. So there are a couple of things. So there's the visual mathematics worksheet that is available to teachers who are interested, and it's a growing bundle right now. It's cheaper mainly because I have like 2 or 3 worksheets, including the proportional one that I just showed you in this webinar. And then there is the middle school mathematics membership that includes all the math resources, all the visual math resources. I'm also including math chats and small groups math instruction, which is coming soon, and all that stuff will be in the membership. And that's also available on the website as of right now. So I'll include all that information if you're interested in integrating visual mathematics into your classroom. I'll include that in the description of this video. So I hope everybody was able to get something from this lesson. It was a real pleasure to engage with you guys during this time, and I hope you were able to take something away from this and integrate it into your classroom in the fall, whether you're doing blended learning or distance learning. So thank you so much. I hope that you guys are doing well, and I will see you guys later.